Today we are going to discuss fundamental SI units, base units and derived units. Those are units applied to measure physical quantities. Seven are the base units as shown in the table: length, mass, time, current, temperature, amount of substance, and intensity of light. If we take an example with the number that is 100, if I add up centimeter, that is the unit of a distance. That's showing small value of distance. If I replace the units with meter, that's showing bigger unit as compared to the centimeter. Same with 100 kilometer, that's showing again bigger distance as compared to the meter and centimeter. So 100 number is defined by units in the term of a distance. If I add up 100 gram, it's indicate the unit of a mass, that is a small quantity. If I replace gram with kilogram, that's showing a bigger value of the mass. There are some drive units that you apply in physics, math, and engineering sector. All drive units are based on those seven fundamental units. For example, speed equation is distance change with respect to the time. If I drop base unit to that equation, so we get meter per second. If your speed in a specific directions, that is also known as your velocity. Same with the accelerations. As we know, accelerations is change in velocity with respect to the change in time. That triangle showing the symbol of a change. If I drop the units into the equations, I get meter per second. So acceleration is meter per second square. If I further add more example to clarify the drive units, we have a force applied on a mass produces accelerations. I drop units into the equations. So mass units kilogram, accelerations unit meter per second square, that is equal to Newton. If you applied a force on an object covered a distance, so that is known as a work. So work is a product of a force into the distance. If I drop units into that expressions, so we get Newton meter. That is equal to the joule. That is the units of work. Same with the power, that is equal to the change in work with respect to the time. So power is equal to the rate of work. That is equal to joule per second. And we know that that is equal to watt. Same with the pressure expressions, that is equal to force per unit area, force units Newton, and area units meter square, that is also known as Pascal. We observe, we define different type of a physical quantities by using a derived units, and all those derived unit depends on base units. And one more important point I need to clarify: when you're working on a set of a units, for example, you have a force 1 kilonewton and distance 10 meter, you find out the work. So you keep your unit consistent. Distance value in meter and force value is kilonewton. So you convert kilonewton into the newton because we don't have a distance in kilometer. Or you can convert distance into the kilometer, then you multiply with force to get your work. So you can move either way. 1 kilonewton is equal to thousands newton, and distance is in meter, so you multiply this with 10 meter. In that case, you will get your work in Newton meter. That is equal to 10,000 joule. Hopefully, you find this video very useful. I will see you again. Thank you very much.